Hi, welcome to VideoMathLessons.com. This is a Algebra 2 and Trigonometry quick lesson. This is lesson number 22, Trigonometry, Equations, Part 1. All right, so let's jump right into it. So this is like the basic part of equations. What we have to do is, they give us an equation here. It says 2 tan c minus 3 equals 3 tan c minus 4. Now, don't let the c mess you up. Usually you're used to seeing it as x or theta, right? Usually that's theta you usually used to see, which it's just an angle, so it doesn't matter. Now, down at the bottom here it says, for all values of c in the interval 0 to 360. Notice it is not equal to 360. Now, the reason why is they don't want you to repeat 0 and 360 are really the same spot, so they don't want you to call coterminal. They don't want you to get the same answer. So let's take a look at this problem. So 2 tan c minus 3 equals 3 tan c minus 4. So what we have to do is get all the tangents to one side and all the regular numbers to the other. So I'm going to subtract 2 tan c from both sides. So this gives me tan c minus 4 on the right and a negative 3 on the left. I'm going to add 4 to both sides. So I get 1 equals tan c. Now, what I'm going to do is I'm going to use my calculator. Now, this is also, what you need to notice is this is a positive 1. And that's actually going to come up with this, the ASTC, all students take class, all positive, sine positive, T tan positive, C cosine positive. So this is a positive one, so that's telling me it's in quadrant 1 and 3. And what we're going to do is find the reference angle. So I'm going to use my calculator. I'm going to punch in second tan 1. Now this is a special angle, and you technically should know it, but if you didn't, I'm just going to use the calculator. And this calculator is automatically got reset it. It's in radian mode. So you make sure your calculator is set to degree mode. The only time you're going to use radian is when you're graphing trig functions. And also, while we're at it, might as well fix the other parts. So I'm going to put in a plus bi. And let's go back to the thing. So now I'm going to press second tan, which is inverse tan. Sometimes you'll call it arc tan. And hit enter, and you get 45. It is one of our special angles. So the reference angle is 45. So now what I'm going to do is I'm going to take 45 and drop it in the first quadrant, and I'm going to drop it in the third quadrant, always off the x-axis. Now in the first quadrant it is 45. The reference is 45, so the reference is the angle I'm looking for. Next quadrant, I'm going to do 180. Now, some people are like, how do you know if you're adding and subtracting? Well, you're going to look at it. If you go past 180, you add it. If you're behind 180, subtract it. So we're going to do 180 plus 45. And many of you just know this off the top of your head what it is. That's okay. If you don't get it wrong because you didn't use a calculator. So I get two angles, 45 and 225. Let's try another one. Find the measure of the angle theta from 180 to 270. Well, that's telling me it's going to be down here, 180 to 270. I'm going to be down here in the third quadrant. And not only that, it's telling me that since I'm in the third quadrant, since it's T, my answer, when I do this, I should have like a negative in here or something. So let's just, nice and easy, be careful. So let's try this. I'm going to get the cosine by itself. So the first part is I'm going to move the 1 over. So I'm just going to rewrite it. I move the 1 over using inverse, so I get negative 1. Divide by 2, cosine equals negative 1/2. Now once again, this is one of our special angles. You should know cosine of something equals a half. Notice I'm not going to do the negative. Now I'm going to do second cosine of positive half. I'm not using a negative. This negative just tells me the neighborhood. It tells me I'm going to be in quadrant 2 or 3. That's what the negative tells me. The half is actually going to tell me what the reference angle is. So if you don't know it off the top of your head, you're going to press second cosine, 1 divided by 2, or you could just punch in 0.5. And you get 60 degrees. 60 is the reference. 60 is over here. It is not in this quadrant. You're going to add 60 to that part right there. Now, you're past 180, so it's going to be 180 plus 60, so you get 240. And if you don't know it, you just punch it in your calculator. 180 plus 60 equals 240. So the answer is 240 degrees. You can check this. So if I type in 2 cosine 240 plus a 1, it better equal 0. So let's check it. So 2 cosine 240. Make sure you close the parentheses after the 240 plus a 1. And just like magic, we get 0. Now what if you left the negative on this thing at the beginning when you did it? All right, so let's try that. Second cosine, because a lot of people do. Second cosine, negative 1/2. And you get 120. Now, take a look. 120 is up in this quadrant. You'd still have to get to this somehow. And it's not impossible. You do 120, that means it's 60 behind. So you're going to go 60 above 180. So you can get there. It's a little roundabout. But it's doable, so just be careful. Okay, now the problems get a little more complicated. Find the value of x in the interval from 0 to 180, so quadrants 1 or 2, that satisfy this equation. Cosine squared x minus 2 cosine x equals 0. Now, this is a quadratic because it's a square. I could use the formula or factor it. I could even complete the square in it, but that's overkill. I'm looking at this. I got 2 spots. This is a greatest common factor. I'm going to take out a cosine x from both parts, and I'm going to get cosine x minus 2. Now, what if you're like, oh, I can't factor cosines? Well, then you're going to look at it as just x squared minus 2x. And then you're going to factor it just like x is. But it's not x, and at the end, it's not x. You swap it out for cosine x, cosine x. Either way, it is doable. You set each side to 0, so cosine x equals 0, and cosine x equals 2. Don't forget the x's. People sometimes forget those. Be careful. Let's take a look at this cosine x equals 2. I'm going to press second cosine 2. So we press second cosine, hit enter, and we got a problem. So now a lot of people, I'm going to press 2 for go to see where the problem occurs. And it's saying they don't like this. It doesn't like this. And if you think about your cosine curve, it goes from 1 to negative 1. 2 is way past where I'm supposed to be. 2 doesn't work. So it's a reject or something, or no solution on this side. No solution. That's even better. Now, I'm not going to circle. I'm not going to cross out my work. I'm not doing anything. I'm just going to write no solution for that side. This side I can do. So if I look at this problem, the graph I made, where is it 0? I'm looking for these 2 spots. So what I could do is I can press second cosine, and I'm going to put a 0 in there, and it comes up 90 degrees. Well, that's this spot right here. So that's 90, and if I wanted to find this, I could, think about this is counting by 90s. So it's 90, 180 in the middle, 270. At the top, they say don't go past 180. My answer is only 90. You do not write 90 in no solution because that means there's no answer. It's just 90. You could also look at this from the unit circle. Where's cosine 0? It's where the x value is 0. And that's how you could also get 90 and 270. So it doesn't matter how you do it. Just make sure you can do it. Now, this is a quadratic, and if you don't like this quadratic, I'll change it to x squared. So now people feel comfortable with this. So I'm just going to factor. It's like nice and easy. X plus 2, x plus 1. And you're like, oh, this is nice. But it's not x. It's sine x. So I'm going to change it back to sine x plus 2, sine x plus 1. So this is sine of x equals negative 2. Sine of x equals negative 1. Now we just talked about this 1 and 2 thing. Same thing for the sine curve. On a sine curve, it's, 1 to negative 1. So negative 2 is bad. This side has no solution. The sine negative 1, I want the y value to be negative 1. I'm looking at that spot right there. I could use a calculator, press second sine negative 1, and I get negative 90. They don't want negatives. They only want positives. So what is that negative 90? Well, negative 90 is this position right here. So it's really 270. This also comes from when you do the unit circle, the x and the y. So I'm looking for where's y negative 1. That is reason it's at 270. So the answer is 270. Do not say 270, no solution. The answer is just 270. And you could plug this in and you could check it. I'm pretty confident in it, so that's why I'm going to leave. Well, that's the first part. That's part 1, so hopefully this helped. Remember, hit up the next parts if you need more help. Come to the website, and that's where you can find them pretty easily. So have a nice night. Thank you.